So I'll introduce myself. So I'm Abhijit. I'm the project lead for OpenFlow plugin. With me is Anil, who is one of the main contributors of on the project, and Jamo, who has been the test architect for the OpenFlow project. So, today we'll be going through the project overview, the architecture, high-level architecture, an example use case, what we accomplished in Lithium release, as well as the plan for Beryllium. And then we'll close out with the potential areas for contribution from the community, from all of you guys, whoever wants. We are really welcoming that. And the last is references, and then we'll have the Q&A. So we'll start with the project overview. So we started this OpenFlow plugin project in the hydrogen release, and it was initially it was a collaboration between a few of us in Cisco, Ericsson, and IBM, and it's one of the first community projects, and it has a participation from a lot of people from like all these companies, Cisco, Ericsson, HP, IBM, Red Hat, TCS, have participated in past and now. So I've just kept their names on the screen. We do meet every week, every Monday at 9 a.m. Pacific. And if you would like to participate, that would be the good venue to start. It's a project which has had a lot of code changes so far over the last 2 years. Of course, we have had like close to 1,000 commits and around 160 kilolines of code. And we have had commits from folks who are like around 60 people who have contributed to the plugin project. And we've had 313 bug fixes. I'm just saying this, maybe by now there might be a semblance of stability. It is still not stable, but it's much better. It's quite stable compared to what it was, and with respect to the different OpenDaylight project, is reasonably stable project right now. And it's thanks to a lot of the test work that was done by Luhrsen and Jamo. So currently active, it's a lot lesser than the 60 number. And so in the Lithium release, we had around 6 or 7 people who were actively contributing towards the. So where does it fit inside the OpenDaylight ecosystem as such? Why does this thing, okay. So as you see, the Lithium project dependency diagram, it's right in the middle of the project dependency diagram, and it's an offset 1 project which has key consumers from OVSDB, GBP, SFC, VTN, the VPN service, the L2 switch, and many other projects which are consuming OpenFlow plugin projects. So, I mean what it means is usually there are a lot of people screaming at us. I'll just hand over to Anil for the high-level architecture.
Am I audible back there? Okay. So yeah, this is a high-level architecture of, I won't say it's an OpenFlow plugin, but it's a high-level architecture in how OpenFlow plugin fit into the whole controller architecture, okay? There are a lot of boxes and a lot of arrows, so let me try my best to, explain it as simply, as simple as possible. So let's go by boxes first. So application is, these are the application where you actually consume the OpenFlow plugin. Okay, so these are the consumer of the OpenFlow plugin. These are not just 3, okay? There are many others, but boxes. I don't want to put more boxes here. Now, then we have OpenFlow plugin component, that is southbound plugin, and within a plugin component we have, if you see on the top side, these are basically services which we are run within OpenFlow plugin. You can say these are kind of, convenience services which do some of the job on behalf of, applications for them, so that application don't have to do it. And these applications interact with the OpenFlow core plugin. That core plugin is basically implementation of the core thing, So, and OpenFlow core plugin defines Yang models, okay? And now, because we are talking about Yang model, let's go to this mid page that we call controller. When you say controller, it's not basically OpenDaylight controller, it's a controller project we are talking about. So controller project has a MD cell that is basically heart of ODL. It's a center of attraction for all the projects. So it allows, it actually enable a channel for different modules to talk. That's the way how northbound applications like OSDB, VTN, GBAP, they talk with the southbound plugins like OpenFlow plugin. It has many other features, like it provides you a routing of RPCs and notifications. It provides you a data store mechanism. So yeah, it enables a lot of channels which these applications consume, and it's basically provide a bridging between OpenFlow plugin and applications. So this below piece is basically OpenFlow Java driver. It basically do the encoding, decoding. It do the connection handling with the switches, and below that these are the guys which we need to manage. Okay, so it can be any OpenFlow switch. It can be hypervisor-based OpenFlow switch. It can be physical switch. Doesn't matter as far as it's talking the OpenFlow protocol. Okay, these are about the boxes. Now let's try to understand how all these things work together. Okay, let's go, example-wise. So first activity is to do anything on a switch. You have to connect that switch to the controller. Okay, so consider one of the switch actually. You in the case of OVS or switches, you do the configuration. You set a manager for them or set a controller for them. So switch attempt to connect to the controller. That connection goes to OpenFlow Java driver that accepts the connection, and it does some initial handshaking business. It sends a hello packet, features, and all those things. When it's done with verifying there's a valid OpenFlow switch, it actually notifies the core plugin saying, I got one switch, it's a valid switch, it's an OpenFlow switch, and these are the attributes which I got from it. And then core plugin basically sends few more messages to get some initial level of data about this switch. And then they ask inventory manager to kind of write that data into operational data store. Okay, so how OpenFlow plugin basically notify the inventory manager is through the notifications, and these notifications are defined in a Yang models. So OpenFlow exposes Yang models that actually defines groupings of model, basically define a model for OpenFlow constructs. It defines RPCs, it defines a notification. So let me give you one simple example of a notification. So whenever any port goes down on a switch, it actually switch send a async message saying my port is down. That goes to the Java driver that decode that message, and it figure out this particular event is about port down, and then it notify the core plugin saying this port down happened. And then OpenFlow core plugin actually takes it, and it actually create that notification, Yang notification, and pass it to the inventory manager. And inventory manager is basically listening all those notifications. So it get the notification, it's okay, port down, and let's do whatever cleanup I have to do about it. And that's how this thing's notification works. Now once the switch is connected, the next popular activity people do here is installing a flow. Okay, so assume any of these applications want to install any flow. What they do is they create a flow body according to the Yang models, which OpenFlow plugin exposes, and they write that flow into config data store. Now forwarding rule manager is listening on those data changes. Okay, so you get notification from a data store. So you have to obviously subscribe for that. Once you subscribe, you get a notification. You get a notification saying, somebody wants to install this flow and this is the data with it. Forwarding rule manager take that data, it decode it, and it say, okay, this is the flow mod I have to construct. It create a flow mod out of it. Flow mod is basically open flow action. Okay, you send it down to the flow mod, and it say, okay, flow mod means I want to install flow, add flow, delete flow. So the flow mod is a wrapper of that. So it creates a flow mod, it sends it to the core plugin, and it sends via RPCs. And these RPCs are defined in Yang models. Okay, via RPCs, those flow mod goes to the core plugin. Core plugin know, okay, this is my destination target switch, and that's where I have to send the flow mod. Once you call that RPC, plugin will take care of that. It create another instruction and send it to the Java driver and says, okay, this is my model-based data. Now you have to kind of convert into a OpenFlow protocol wire format and send it down to the switch. And that's where your flow get installed. Okay, that's where the whole architecture, this is the high-level control flow, how things work. Okay, there are a lot of complexity in terms of how RPC notifications work. So I try to make it as simple as possible, so it can give some mental hooks on at a high level how it works. So any question in this slide? Yeah. Mm-hmm. Well, yes, you have to do that, because that is all based on the experimenters, right? So you have to do that business here down in the driver level. You have to do that in OpenFlow core plugin level also. Yeah. Yeah. It was about using extensions, right? Nisira extension. So this extension is provided in all three constructors of the flow. There is a metadata, is a match part or action part, right? So they have various extensions. So we are using Nisira extension. We provide support for that, which OVSDB project and GBP they use very extensively. Yeah, you have a question back there.
So when we show the core plugin talking to the FRM or the statistics manager using RPC or Yang, I'm shown direct connections. But really, aren't they also going through the empty set?
This is what you're talking about? Yeah. So why I don't want to, these straight arrows are confusing. So I kind of go in a board way, so I will say, okay, this is how it happens, okay? But yeah, this is the way it, simple way is, okay, they call RPC, it goes to the plugin. So I kind of cut off that route, but this is basically a route. So it goes all through empty cell. Where in case of RPC, it goes to empty cell, then it goes to plugin. In case of notification, it goes to empty cell and again to the application who are subscribing for the notifications.
So is this RPC synchronous or asynchronous? Like if I put a flow and it fails, will I get the notification right away, or do I have to go?
Yes, so as of now, this is the existing implementation which we has, that is basically async. What we do is, because the flow nature itself is async, so you send a flow, if it fails, it let you know the error. It never says, okay, it's successful. If there is an error, they will say, okay, this is the error. Now the point is, at a switch level, plugin level, you can do that in a way. You can kind of wrap it up, make it sync. So we have we have alternate design for that. There we are doing this thing. So yeah, it's doable. It's very implementation is specific here, but the basic nature of a switch itself is async. Okay, so the existing implementation which we have, we send RPC, we send a flow mod, and we wait for an error message, and we pass the error message as a notification to all the applications to say whatever you tried with this transaction ID, that flow actually failed. So if you want to take any action on that, you can take it now. Okay, if you don't have any question, I can move to the next slide. Okay. Sorry. So your question is, So success is basically, switch doesn't say anything, right? It's a success, okay, it's done. You verify it by operational data store, because once you fetch those data from a switch through a statistics manager and you put into, that way you know that your switch is kind of, flow is kind of successfully installed into it, right? If it fails, we don't really have any notification as of now, but these are kind of potential items which we are planning for the next release, because they increase the usability of the plugin. which, many people ask me these things that, okay, it fails. Everybody kind of need to listen for an error notification. If somebody is kind of writing an external application, that's very hard for them because you are not putting anything into an operational data store for a failure. So we are not really can get a notification even with the WebSockets. So yeah, that's a potential improvement which we are trying, and hopefully we'll see in Beryllium release.
But could it be just a field in the operational state is not worked? Could it just be part of the operational?
Yeah, so that is what we are trying.
Here in the operational?
So we are not putting anything, the flow is not, operational is basically a network state, right? It's a switch state. So if that flow is not there, we don't really put there. It means that flow is not there. But the point is, you get a failure for that. So you can put something into operational which actually says, okay, that flow installation failed, right? So that's more about, user consumability perspective of this. So that is something which we are definitely looking into it. I know this is a pain and we are thinking over it. Yeah. So I think there was a question from that side. I'll take that first. I'll come to you. Yeah. So MD cell is very agnostic to the context. So the question he was asking is, what if somebody installed the duplicate flow here? The flow is there. You change the metadata. Say flow name is flow name 1, flow name 2, and then you install the second flow, right? That's basically the flow is unique by their match. Whether if they can be duplicate in this case. What he's saying is whether MD cell can, detect those duplications or not. So my answer to that is MD cell is agnostic to the context of the southbound plugins. MD cell provides you very open interfaces where you put a data into the store where those are modeled by the Yang model. Okay, they don't really have a context about southbound plugin. They don't really know the data you are putting is basically OpenFlow data, and that MD cell should not do it in any ways. Okay, they can do some validation because obviously you are kind of designing a networking solution here. They can do some validation, but these are very extensive validations or verifications which you have to do at your plugin level. That's the job of the plugin. Yeah. So there was a question. Yeah.
So when your network comes up and both channels are established, can you just describe a mechanism how a application has a requirement for table features or capabilities? How is that checked? Is it everything populated in the stat manager, and then the app can do a query to the stat manager across all the elements, or maybe you can walk through that?
So in the existing design, right, statistics manager is one entity that actually send all these requests to the switch, basically to all the connected switch.
But not on its own. I mean, the app must tell us that manager.
Yeah, so I'm coming to that. So one thing is it actually fetches all those things. Okay. Now the point is somebody don't want to use a statistics manager for some reasons. Then there are RPCs which they directly can call. They say, okay, this is my RPC. Just call it and say get all the data. Okay, and then statistics manager will listen to that and it actually dump into operational data store. So you can directly call the RPCs on specific switches also.
I think I'll just quickly.
I think it's like
let me just quickly add to your answer. Actually, I think what you're asking for is what do we do with the table features request? How do we handle it? So in the Lithium, we have added a minute feature where you have when the switch gets connected, we will send an empty body table feature request, and when the response comes back, it will get populated into the inventory manager, into the inventory. Unfortunately, so far we have not hooked it up, and it's not been extensively tested yet, that mechanism.
So this is basically we are getting read-only data.
Yes.
We are not really doing any table feature configuration as such. Whatever existing configuration is, we can tell you this is the existing configuration. You can take, application can take decision based on that. So yeah.
I think you answered my first question, but I was asking to see if the OpenFlow plugin will be supporting the cluster mode. I think your answer is no, right? And
Clustering?
the clustering, basically, but this
Yeah.
what is running in the clustering mode. This is my first question. The second question is like, do we have any problem data to show how fast you can handling the flow from the restaurant when after you get in the restaurant all the way to the basically it's like the reason is like in the OS meeting, like all those guys say they can claim the 1 million flow per second. Possible. So I want to see what's the data you have.
Okay, so he asked two questions. The first question is whether we have a clustering support or not. Second thing is whether we have any performance number which actually shows, how long it takes to kind of anybody send a REST conf request and get kind of, programmed to the switch. So to your first question, I think clustering support is kind of planned for this release. Okay, so that is something which we are going to do. So for Lithium release, no, there is no clustering support for that. Although we have all the tools which we need, right, sending master and slave messages and all those things, those tools are in place, but the exact clustering algorithms and all those things, that mechanism is not in place. That is something which we are planning for this release, next release. And to your second question, I'm not sure whether we have a very specific number about, one request sent from then and how long it takes to go there. Okay, many people did really good testing for that. Jamo is going to share, some of the details about this. Few people, I think Steve is here, he did very extensive testing of this thing, so he can probably provide you feedback. If you're asking me an exact number, that number I don't have. So Ian is here, he did some of these testing here, so. Is not there. Okay, so he did some of those testing, and he has some of those numbers, but it depends on environment and variables and all those things. So yeah, but this is something which is in the plan, and we definitely will publish it because people are looking for this, and we know that. Any other question? Okay, yeah.
From the perspective of an external application using RESTconf,
Mm-hmm.
is there a prescribed mechanism to know if a flow installation has failed, besides polling, operational or comparing to each other?
Sorry, I didn't get your question exactly.
How
So,
does an external application figure out if a flow
Has the installation is
switch or not?
the installation?
yeah, so that is basically we kind of send a multi-part request and we fetch all the flows because with the standard itself, the problem is if you send anything, if anything successfully happens, they keep silent. They are not sending anything because there are obvious reasons for that, I believe, but for an error they send it. Now the point is internal application, they can look for the errors, but the problem with the external application is, as I was telling to Flavio, that we are not really putting anything into the data store. People can use WebSocket and they can get notification, even the external application, but we are not really putting anything into it so that you can get notified. Okay, that is a very valid problem, and we understand that, and that's something which we are thinking around it, and hopefully in this release we'll get something around it. So external applications will be happy about it.
Quick follow-up, is there another mechanism that can be tied into internally that could notify your application through WebSocket or some other?
Yeah, means you can always write applications, right? You can always write your own module which actually can hook up into the notification. They can hook up into flow installation, and they can figure out all those things. They can write something to a data store. That's up to you. You can write your own custom Yang module which actually does that business. Okay, so that's possible. Okay, so for a time's sake, let's move to the next slide. We have 40 slides or something. Okay, so the example use case. So OVSDB project is one of the example use case. You can say I am biased because I worked in this project. I want to make Flavio happy, but this is not the only project. We have a GBP who extensively use it. We have VTN project that extensively use it. I can name 10 more. Everybody kind of need to install Flow to the OpenFlow. So I don't want to go into detail of this, but what OVSDB consumes from OpenFlow plugin is basically it checks for a node connectivity. OVSDB create a bridge and it is to connect to the OpenFlow controller, and that is something where when it connects, we want to know whether it got connected or not. So okay, this is something which we are using from OpenFlow. Flow installation, modification, removal. This is something which which OVSDB is consuming from OpenFlow. Nisira extension is something which we heavily consume, GBP and OVSDB both. And the packet recently we started using packet, and we are listening for a very specific set of packets to figure out some gateway resolution and stuff. So these are the four main features of the plugin, and OVSDB and GBP both are kind of consuming it. Okay, so I'll hand over to Abhijit. He'll take care of this.
So, yeah.
So are there extensions that if a third-party application wants to get packets that you're getting to deal with it?
So extension, it depends. So what extension are those? If those are vendor-specific extension, that okay, some vendor wants that these are my extension, whether they want in a repo or not. that is a different question. I think we need to kind of discuss on that because we need to set some rules about it, what all we allow, whether we allow everything into a repo or not, which people might not like. So there is a discussion going on that, so we hopefully will come with something. But I think vendor, most probably they will provide them a repo where they can push it. Now the point is whether they can write it or not. We have a framework in a place which folks can consume, anybody, okay, and they can write their own extension and they can plug into it and make it work. So that's there. Yep.
You mentioned about listening for packaging, right?
Yep.
So basically packaging is used for punting unknown packets to CPU or maybe controller. So why would
Yes. So
which is involved in just configuring the switch channel listen for the any data package that goes for the
So punting is not about unknown packets, right? You sometimes look for unknown packets also. So with OpenFlow 1.3, what happens is you match on specific packets, specific traffics if you want to punt it to the controller. Okay, otherwise going to get dropped. It's not like 1.0 we used to have everything goes to controller if there is no rule, right? That's not a case here. So here, just like OVSDB, they just look OVSDB and GPP, they just look for an R packet. That's it. Okay, and that is for a very specific R packet. So they install very fine-grained rule to get that specific packet. So that way you can reduce the traffic. It's like very negligible traffic there. So that's the way it goes. Okay.
So quickly what we went through with the lithium. So as part of the release, a few of the main deliverables which were done was one of them was migration of the Yang models from the controller to the OpenFlow plugin project. The migration of applications. We'll go into a little more detail about these. Then we had an alternate design for performance improvement during this lithium release. And there were a few features which got added. And there were a lot of integration and CI test improvements that Jamo will go through a little later. So as far as the migration of OpenFlow Yang models, so earlier the OpenFlow specific Yang models were present in the controller project, and these 3 or 4 of these model flow base, model flow service and statistics, we had people have to do it in 2 places. If any changes have to be done, we have to do it in 2 different places. So the thought was to have all of these OpenFlow specific models to be moved into one place for avoiding any kind of a confusion for the developers. So in a way, this is more of improved project maintenance as such, not I mean, other than that, there's not much of impact with this. And the next one is a similar effort, was migration of OpenFlow applications. And there are several of these applications that what people commonly call them as the network service functions, NSFs, which were present in the controller project, the forwarding rules manager, the statistics manager, the inventory manager, and the topology manager. So people had to, when you had to do a change in this, people had to do the changes in 2 different places. One is in the OpenFlow plugin and one was in the controller. So the idea was to have all of these OpenFlow specific NSFs into a single place to avoid any confusion for the developers and make the maintenance a little easier, because otherwise there would be a lot of issues sometimes with the with some patch being put into the controller but not in the plugin, and or some out of sync issues for sometimes a little amount of time. So as such, this is no major impact in terms of the consumer, but the stability impact is it's improved project maintenance. The next one is a big redesign that was done. There was a new performance improvement design proposal which was implemented, and it's to improve the stability and performance as well as the user experience. The impact to the consumer should be transparent. Uh, as far as the current status is concerned, in the lithium release, both the existing design, which we commonly refer to as the helium design, and the alternate design, the lithium design, are both of them are available as options as of lithium release. The existing design, the features are under the features-OpenFlow plugin, while the alternate designs, all of them are like under OpenFlow plugin, features OpenFlow plugin LI, the LI version of it. So you have the LLDP speaker, you have the FRM, and all these things are like you have a separate lithium version of it as well. So yeah.
So is that actually telling us what the performance improvements are? The
Uh,
next slide?
Uh,
You're saying there's a statement
so-
of performance improvement. You didn't tell us what the improvements are.
So, I mean, Jamo will cover a little bit in the detail, but I mean, in this release, we have not had. I mean, we've had some improvements, but they were fairly similar, and also people have not had a chance to migrate to the new plugin, the new design also. Yeah.
What does it take for applications to migrate
If that's it. I mean,
So it depends on what actually you are consuming from the OpenFlow plugin. Okay, so if you are not consuming any direct APIs, that too very specific to, let's say, statistics manager or something, you should be good. You just change your features from UI to LI and it should be good, because as far as you are consuming data store, I don't see any major hurdles you will face there. But if because of some design choices we made, we need to kind of disable some of the statistics manager related RPCs and notification. So if somebody directly consuming those, they have to move to data store, to kind of get the change notification from a data store and make things work. So that's where they might have to do some work. Yeah.
we have we have the groups and meter support. I think it's we have a coverage spreadsheet, and if you can follow up with me, I can forward you the.
So 1.3, whatever is there in group and meter,
Yeah.
those things are there.
Yes.
What about QoS?
The QoS, only thing we have is in terms of the meters, that is part of the OpenFlow 1.3 spec.
Okay.
Yeah. So, as Anil mentioned, there are this is just a comparison matrix between the two designs. The existing design doesn't have any changes with respect to the API. Alternate design has most of the things are there, and there are some new things, but the notifications except packet-in are most of them have been moved out. So things like the stats manager and the inventory manager, now it's internal to the OF plugin. So there was no reason for these to communicate through the MD-SAL. So I mean, Anil had this diagram where he showed this going through the MD-SAL. Because these are applications which are within the OpenFlow plugin, they don't have any reason for going through the MD-SAL. So that's why, I mean, that's the major change. Stats are, I mean, the advantage for this is the stats is not flooding the MD-SAL, and this is entirely, it's a bit faster and reliable mechanism and has better control over the statistics scrolling. But there are consequences with respect to the applications outside of OpenFlow plugin. They cannot query the stats directly from the device. They need to listen to the operational data store, changes to the operational data store. So that is one of the consequences. The other mechanism that was changed was, this is a partial list. It's not it was a major change, but it's a partial list. The other was the RPC completion. In the existing design for things like the flow meter and the group management, after the message is sent to the device, the RPC will return and will be provided as complete. But in the alternate design, it's upon the changes upon when it has been confirmed by the device. So the advantage of this is that it's more reliable, like in terms of it provides more information at the end of the RPC result. But consequence is your RPC processing is going to take a little more time. But it may not be, it's something that is a trade-off that you so the second thing, one more thing is that when an OpenFlow device is exposed, in the existing design, it is exposed to the inventory, it's right after the handshake. While in the alternate design, it's after the device has been explored. So the advantage for this is when it's there in the new data store operational, all the information is consistent and the RPCs are ready. But consequences, with device with a large start reply, it might take a little longer to get exposed into the data store operational. But again, this is a trade-off that that might be worth it in many cases. Yeah.
When Luis is running his test and he's loading all features,
Yeah.
these two cannot be loaded together.
They cannot be loaded together, but he has the different tests, I think.
Yeah, yeah. No, that's a good point. You can't turn on OVSDB and expect to use the alternate plugin. You're stuck. So,
But even the two plugins cannot be loaded together.
no, no. One or the other.
I actually don't want to figure out if there's a way to enforce it, but what happens if we try? Can you repeat the question?
Can you use both plugins at once?
No.
Dance.
No, reason is these plugins use library, they listen on same port, right? If you up one, it will start listening on 6633 or 53, and then you start again, that will fail. They won't listen for any port, right? There's a port conflict. Basically, they do the same job. Now, the point is you need two pieces together for doing the same job. I don't know architecturally how that fit, but you need one thing to do the one job, right? Yeah, so we try to make sure that, if people want to move that, it should not be that big of a hurdle, but yeah, we need to take some design decisions which, can give some to-do list in those projects who want to move there, but that's the kind of cost of, doing this kind of work.
So back what you asked about running all the features in system test, we don't use the alternate plugin in that scenario. So.
Yes.
So it seems to me that the API changes, I mean, that's obviously, seems like performance issues. The last two really look like dealing with possible race conditions,
Yes.
correct?
Yep.
Yes.
It seems unfortunate that you have to have a choice between, I mean, I imagine that there are people who have little
Yeah.
sleeps,
Yeah.
basically, in all the places
Yeah.
dealing with RPC pollution or
Yeah.
exposing devices.
Yeah.
It's really unfortunate that
So,
you have to choose between those.
I mean, that's probably the case in the lithium release. In the beryllium release, will probably merge the good. I mean, probably go to one of these and merge the best pieces of both into one. This is actually a partial list of things which has been changed, but. So as far as the new features I mentioned earlier in response to one of the questions, the table features update to the inventory based on the table features response and empty body table features. This has been only tested against the CPQ switch. I mean, if the idea was this was going to be used in conjunction with the DIDM project, the device independent discovery mechanism.
Okay.
So they were going to do some kind of advanced stuff with it. But I guess that will be done in the Beryllium release, how it is used from there. The role request message, this is required for the multi-controller operation. And at this moment it's done in the existing implementation only, but yeah, that will be something we'll have to look into for the alternate design. Jamo is going to,
Done with the boring stuff.
yes.
So we might have to go a little bit faster than you always do this to me, right? The test guy goes last. And
The test guys always get the brunt.
So this is kind of an overview of what we've done for lithium. There's more than 6 contributors, but for the OpenFlow plugin suites, there were 6 contributors, but we have libraries that people helped out with, and so I didn't run stats on that. One guy, Peter, did a great job, and I hope he can contribute at least part-time in Beryllium. So thank you, Peter. If you're watching, he's not here. We added more than 300 new test cases. These are feature test cases, and some performance and scale. Some of our scale monitoring suites, caveat, this is all run in a shared environment, virtual environment, so we're not trying to get the highest scale or the most performance. What we want to do is monitor scalability and performance to see if it falls off a cliff or improves over time or degrades. We had to do the same jobs for both plugins, the alternate plugin and the other one. We have to monitor those. We have to scream and yell when they fail. We have a longevity suite almost done. And what the idea there is take maybe a scale test or a performance test and run it at 50% and then run it for a long time. Right now we're shooting for 24 hours, but configurable, we can do it for 5 days or 5 months, whatever. And then when there's important bugs found by the community that we think we never want to see again, we can write CI and put it in some job, and that will let us know. So we'll try to go, there we go. So for stable lithium, now we have jobs for the master branch and we have jobs for helium, but for stable lithium, we had 30 jobs, 2,100 test cases. They run on every merge. So when things break, we can find out fast and hopefully chase this guy down, right? Fix it. So it's a really good litmus test on how stable we are. We need to be all passing for the release to go out. So this is the plots we have in Jenkins. Anyone can log into Jenkins and check these out. We're scaling to 500 switches. We're using Mininet with OVS underneath, and we can get 500 in one instance. We do just a simple linear topology. We have 2 jobs. The one on the right does not look so good. We need to investigate it some more, but it's doing it slightly different. It's building the switches up and adding 10 and checking, adding 10 and checking. The one on the left will do something like add 100 and then check, delete 100 and check that they're gone, and then add 200 and check. So the one on the left is a little more stable for us. We need to look into the one on the right. If someone wants to help, I'll bootstrap you. Link scalability, not good. So what we have a bug, right? It's an open bug, so we can track it. When that bug gets fixed, we're expecting link scalability to go way up. We're also told that the reason we're failing is because of a null pointer exception, and then that's harmless. So ignore it, but I don't want to ignore it. So we'll hopefully get the bug fixed. This is a full mesh. Sandeep is around here somewhere. There he is. This is your test, man. Thank you. Full mesh topology, just add another switch and make it full mesh and get the most links that way, right? So, and it's again with Mininet and OVS. Yeah, right, that's by default. Yes. Yes, it does. We have an older version of OVS in the Linux Foundation that we're using for these. And if you use the newer version, it behaves slightly different and we'll need to adjust the tests. But in theory, it should be fine. Just some work. Host discovery. This actually depends on the L2 switch project. Without L2 switch project, we don't discover hosts. So this is not in the OpenFlow plugin test repo, but I think it's good work, so I wanted to show it. We used to have out-of-memory exceptions, bug 3326. I think it's still open, but when I was preparing these slides, I saw some failures that were not related to that. So if somebody wants to file a bug, there's the question mark you can fill in the slides. Contribute. So yeah, we do one switch and then we just add hosts. So some performance-related stuff. We have northbound flow programming, so REST calls to the northbound API. The top box is one test, one job, and you can see the details. We do 63 switches, 25 flows per request, and I think that's why we get such a big number, 1,600 flows per second. The next test is 10K flows. By the way, we're using, what's the name of the tool? Jan wrote it originally. Packet Blaster, or no, that's not it. Anyways, we have a really cool Python tool that we're using for these. So we do one flow per request, and we do it in 5 threads, 2K flows per thread, and we get a much lower number, but I think it's because, right, we're batching the flows. The alternate plugin on the bottom versus the default plugin. So there's slight performance improvements over here. Yeah, no, no, it's the other one. Sorry. Cbench. This is the existing plugin, default plugin. Throughput mode, latency mode. Again, we are not trying to find the best performance. We're trying to monitor performance. So if it falls off a cliff, right, we know something broke. So we get, there's the 2 modes, latency mode, throughput mode. We get 100K in throughput, 16K in the other. And then I have another similar slide for the alternate plugin, and the performance is almost the same. This is southbound, and this is Cbench, and that's a very narrow tool, but it is what it is. So this is how it works. We had decent performance on the far left. You can see the dots. And then somebody broke it. And then somebody screams at somebody. And it takes a while, maybe a week or 2. But after everybody does their work and a few Garrett patches, we get a job that's triggered, and boom, performance is back. So this is something we didn't have before Lithium. It just gives more visibility. It allows some history to see how things are going. So I think it's working well. What I referred to before, we had a denial of service bug found in Helium and fixed in Helium, and then found again in Lithium and fixed in Lithium. So like, we don't want this back again, right? So 11 lines of robot code running in the job, and it's continuously passing. If it fails, we know we got the bug back, and we don't need someone in the wild to report it to us. So I think, yeah, that's it for the testing part.
Yeah.
Got a question? Not following. Did you hear that?
No, I did not get the question.
Well, if you are working out of repo itself, you can pull that patch, build it locally, and use it. Okay. Integration also build, I think nightly distribution something, which actually will have that patch. You can get it and you can use it. So
you can go through Garrett and find a patch and then follow some links to get. Yeah?
Officially, I put it out the first video. And install it, working fine, never see the bug, find the bug. Somebody fix it. So if they do is that rather than putting the whole thing yanking out, you can put that particular bug fix.
Yeah, just take the patch code, right?
Yeah, I think we can do that. I'll get back to you. I think we are running out of time, so let's cover it up and then I'll get back to you. So let's talk about the future. So we are planning for clustering support. This is our top priority because, you know, people say without clustering, no. So we have to go that way. These are a potential item. New feature, we are planning to do a flow entry eviction, a flow vacancy events. These are specific, 1.4, and people, kind of came up with a request to kind of implement those things. And we have people who wants to contribute that. We are improving again. We are giving a lot of work to Jamo to do the integration testing, CI improvement. So he can't lie. So we always give, keep getting these things to us.
It's
We'll
at the
fix
bottom
it.
of your list here.
Sonar code coverage, which we, it's a very iterative process, and we keep doing that, and that's also, one of the priority for us. Documentation, yes, I know it's the end of the list, but it's also a top priority. Okay, and we are kind of talking to the.
We keep the ones which are most important at the bottom of the list.
Okay, so clustering support. So clustering actually will provide us 3 benefits. One is HA. Okay, so you have more than one instance of the application running, so that's provide you HA. It provides you scalability in the sense rather than connecting all the switches to one controller, you kind of distribute your switches to different controller. Okay, I'll show you how we are thinking of that. Persistence clustering provide you a persistence. So any user configuration that is in a config data store that get persisted. Okay, so these are the 3 benefits which we get out of clustering. That's is very critical for us to go that way. So yeah, this is very high level view of what I have shown you in initial slide. So we have application, we have a data store in between, then you have plugin. These are the 3 instances running. So yeah, this slide is kind of influenced by one of my buddy's slide. So we use this slide, Kamal sitting there. So I just fill in more colors to this buddy. So this is how we do it. So we have a 3 instance running. So it's a 3 node cluster. So it gives you HA. And then you have 2 switches. So if you look at a switch 1, the master node for that is node 1. For a switch 2, your master node is node 2. But these switches are also connected to other instances. So if you look at the second switch, it's connected to all the 3 instances. And the switch 1 is connected to 2 of these instances. So it depends on, user can do their own configuration, how they want to connect switches to the controller. So they have a freedom of, doing this initial configuration. And that's how we kind of get HA. Your 3 application instances are running. If any controller goes down, you have 2 application instances running. You have a persistence because of a data store and a scalability by distributing these switches to controller. So it's not a standby mode. Okay, it's like 3 controllers there, 1 is not active. It's all are active. They are managing their own devices. Okay, that's where we can scale it in a horizontally in a better manner. Okay, that's where it gives us scalability. Okay, so Abhijit will kind of go through all these things, and then we are open for questions and answers.
So these are a couple of features from OpenFlow 1.4. I mean, these are implemented as extensions extensions to the OpenFlow 1.3 spec, but they are officially part of the OpenFlow 1.4 spec. So this, like the first, both of these are very related features, and they require also support on the OVS side or the switch side. This is a mechanism to enable the switch to automatically eliminate entries of lower importance to make space for the newer entries. Since I'm a little out of time, I will not go into details of it. But this is just like a prioritization mechanism where a switch can remove entries which are lower importance, and this is achieved by a new field called flow importance into the flow. And the next one is a related one. It provides a mechanism for the controller to get an early warning based on the capacity threshold which has been chosen, that your flow table is getting full, and it allows the controller to react in advance to remove a set of flows if it thinks that these are the lower priority flows. And I think this is the main thing that we have, potential areas of contribution. I guess there are a lot more areas of contribution, but these are a few of the things that we really require some community help. One of the most important would be the fixing open bugs. We would like help in the contribution to the CI/integration testing. The documentation, as we said, was a very high priority. That's something. Okay, here I have my priorities set right. The clustering also will. We have Kamal and Anil, but we need more help to make it happen faster, and because this is such a key feature, and as well as it's a big feature. Full OpenFlow 1.4 support is something that will be a priority. The other things we would like to have is stats collection optimizations, where you would collect. You don't necessarily use stats collection for all of the flows, but do it on a per flow basis, where you just do the stats collection to verify a successful programming of flows, to check the operational data store that what Anil had mentioned on, to verify that the flow has been programmed. So this is an idea. It's something that needs to be investigated more. The GBP project, and they have said that this one is also important for them, which is connection tracking. So OVS has the support, the latest OVS has the support of this connection tracking of a stateful firewall feature, which requires some extensions to the OpenFlow spec. And that will be an area it will be good to have some help on. And the last, one of the last things that we want to have is, people have been asking this to be able to filter packetings based on a protocol, so that it will allow the applications to subscribe for the packetings of a particular protocol type, and also create some kind of a user-defined filters to do so. So, as I think someone talked about, was how many people we have. So we have not enough. And you can go and check out these references. I'll upload these slides to the wiki, OpenFlow plugin wiki, but I think there is I'll also upload it to the ODS Summit wiki, ODS Summit slides.
So guys, anyone interested in working on any of these problem sets, feel free to reach out to any of us. Our IRC email and everything is on OpenFlow plugin main page, and we are active on IRC. You can find it at any point of time. So just feel free to ping us. We'll help you to boot up with these things, and hopefully we'll see some contribution from a larger community. So that's it. If you have any questions, Abhijit.
To add to his point, the mailing list would be one of the avenues to ask questions. The IRC channel would be another. And if you have some things, you can always get into the meeting.
We'll be outside if you want to talk.
Yep.